The following two 12-inch aluminum plates are fastened with four 3/4-inch diameter steel rivets. A. Calculate the amount of the normal stress, strain, and deformation in one plate. B. Calculate the magnitude of the shear stress and strain in one rivet. This is a pretty straightforward question. We have two plates which they are under normal stress because we have P acting in here, which is 24 kips, and under this P obviously this plate is going to deform, and we are looking to find this deformation. The area that we will deal with is the area that this force is perpendicular to that surface. So to find the requested parameters sigma, epsilon, and delta, we have to just step by step follow these equations. P sigma is very straightforward. P over area. P is 24 kips, and area is the area of this plate. It's 3 over 4, 3 over 8 times 4 inch. So this is the area that we are looking for. And if you solve this, it's going to be this is inch square, inch by inch times inch, 6.9 KSI. Now that I have sigma, assuming that the deformation will remain in elastic region, I can use Hooke's law and find strain by given based on this given elasticity, modulus of elasticity. So epsilon is sigma over E, and this is going to be 6.9. I'm writing it as PSI by multiplying it to 1000 because given elasticity is in PSI, and this is 10 times 10 over 6 PSI. And you can see that PSI over PSI, therefore epsilon doesn't have any unit. Strain doesn't have any unit. The result is 6.9 times 10 over negative 4. Now that I know epsilon, I can write the equation for the or basic equation for epsilon, which is delta deformation over length L, and we know that L is 12 inch. It's given here, 12 inch. And we can find the magnitude of deformation, which means that epsilon times L, 6.9 times 10 over negative 4 times the length, which is 12 inch, and it will give us something around 0.082 inch. So deformation has unit, but strain doesn't have unit. Now this is part A solved. Part B is going to be something very identical with what we did. First, P in here is equal to the P that we have over there. It's 24 because these are two plates on top of each other. And this 24 is going to be distributed in between these four rivets. Therefore, V at each rivet is going to be 24 divided to 4, and that's equal to 6 kips. Now that we have this, we can find the magnitude of shear stress and shear strain in one rivet. So this is our rivet. Clearly, this is going to be that V, and shear stress, we know that it's following this equation. Tau is equal to V over area. You see it's very identical to this equation that we had here for normal stress. V is equal to 6 kips, and area, this time we are dealing with rivet, therefore it's going to be pi over 4 times the diameter for one rivet is 3 over 4 inch square. It's given in here, you see. And if you solve this, it's going to give us something around 13.4 KSI. Now that I know Ta, very identical equation for uh, epsilon there is for shear strain, and that is this one. Gamma is tau over G instead of E. Here epsilon was sigma over E, gamma is tau over G. We don't have G, but we have E and we have nu. Therefore, we can plug it into this equation and find the magnitude of G. So it's going to be E, which is 30 times 10 over 6. It's given here for, okay, divided to 2 times 1 plus 0.3. If you solve it, we will get something around 11.56 times 10 over 6 psi. Now that I have it, I can plug it into this equation. 13.4 again times 3 psi, which I calculated above, divided to 11.56 times 10 over 6 again psi, and you see that gamma also does not have any unit, and this is around 12, and that's the problem solved.